So in this video, I wanted to go over confidence intervals. All right, so now starting with confidence intervals, we're going to now start to get into a branch of statistics that's referred to as the inferential branch of statistics. And basically what that means is that now we're trying to estimate a population value. So if you remember way back at the beginning of the semester, we said you have two types of data sets. You have populations and you have samples. Populations describe an entire data set, whereas a sample is just some of it. But sometimes in life, it's impossible for us to get the population value of something, right? Or it's very costly for us to do so. Well, in that case, what we do is we take a sample and we use that information from a sample to make an estimate or to make a guess about what the true population value is. And so the first of such tools that we'll use is something called a confidence interval. And so for us, there's going to be two parameters. So if you remember, parameters talk about populations, whereas statistics talk about samples. For us, there's going to be two parameters, two population values in which we're going to try to estimate. One is going to be the population mean, which is mu. And then we also have the population proportion, which is p. So proportion means a percentage of something. All right. And so the first thing when it comes to a confidence interval is that you need to, first of all, come up with an estimate of what you think that value is. And so let's go back to population mean mu. The point estimate, or the value that best estimates that population value of the mean, is, well, the sample mean. So x bar sample mean is the point estimate for the population mean. In a similar fashion, the sample proportion, which they denote as p prime, right there, that's p prime. You see, I covered up the prime. But p prime is the sample proportion. And that is what they're going to use to estimate the true population proportion. Okay, so once you have the point estimates, now you can construct a confidence interval. And what's a confidence interval is, it's an interval. That means there's going to be a lower bound, there's going to be an upper bound. To get the lower bound of your confidence interval, you take your point estimate and you subtract away something that's called the margin of error. The margin of error is just accounting for the fact that you're working with sample information. You're not working with population information. So because you're only working with sample information, there is some wiggle room, there is some error in your calculations, and that's what the margin of error is. So the lower bound is the point estimate minus the margin of error. The upper bound is the point estimate plus the margin of error. So for this video, we're just going to learn how to construct confidence intervals. And then also, once you know a confidence interval, can you go back and can you pick out the margin of error? Or can you go back and pick out the point estimate? All right, and just in this slide very quickly, they just tell us the margin of error is the width of our confidence interval. And it depends on something that's called a confidence level. Okay, we won't get specifically into that until maybe the next video, but just know that when I come back and I talk about confidence level, that just specifies how strongly confident you are in the interval that you calculated. Okay. Here we go. So a student wants to determine the mean amount of snow that a certain city receives during the month of April. She wishes to estimate the population mean, which is unknown because there is not a record for the amount of snowfall for every year. So in this case, the population mean is completely unknown. So to estimate the unknown population mean, she uses sample data to calculate the estimate, and she got a sample mean of 26.25 centimeters. That is our point estimate for the population mean. She also gets a margin of error of 6 centimeters. So they want us to construct a confidence interval for the mean amount of snowfall for this city in April. Okay. And so, as we saw before, the formula for the confidence interval is you take your point estimate. In this case, since the confidence interval is for the population mean, the point estimate will be x bar. And you're going to subtract away, I'm going to just call it E. Okay, and that is your margin of error. So E is your margin of error. And then your upper bound would be your point estimate plus the margin of error. Okay, so once again, E represents, let me come over here, E equals margin of error. Okay, now they may use a different notation, but it doesn't matter. E is the margin of error. So in our case, we take our sample mean, which is 26.25. Okay, and we subtract away the margin of error, which was the 6 centimeters. That's the lower bound of our interval. The upper bound would be the same 26.25, but this time plus a margin of error of 6 centimeters. Okay, as we work that out, we get a confidence interval going from 20.25 up to 32.25. All right, and that is our confidence interval. And so what does this mean? So the interpretation here is that we still have no idea what the population mean snowfall is. But we are pretty confident, or it is likely, that the unknown population mean snowfall is somewhere between 20.25 centimeters and 32.25 centimeters. Let's try another one. So we have a random sample of registered attendees who were surveyed and asked if they learned anything new at the seminar they just attended. The proportion of those surveyed who answered yes on the survey is 0.52. We have a margin of error of 0.04. Construct a confidence interval for the proportion of registered attendees that answered yes on the survey. All right, so we're trying to this time create a confidence interval for not the population mean, but instead the population proportion. Okay, and what that formula is, it's you take the point estimate. So the point estimate for the population proportion is the sample proportion, which will denote P prime. Or even sometimes you'll see a P with a hat on top of it. They mean the same thing. So P prime minus the margin of error is the lower bound, whereas P prime plus the margin of error gets you the upper bound of your confidence interval. All right. So now we just take the information that they gave us. The sample proportion, or P prime, was a 0.52. We subtract away our margin of error of 0.04. And then the upper bound was 0.52 plus the margin of error. And doing the math, we get a confidence interval of 0.48 being the lower bound, the upper bound being a 0.56. So once again, we do not know what the population proportion is. We don't know the percentage or the proportion of all people that answered yes. But we can say that we are kind of confident, we're pretty confident that somewhere between 0.48 or 48% and 56% of individuals who attended that seminar answered yes on the survey that they learned something new. Okay, so once again, confidence intervals are very useful whenever you don't know the population value, but you still want to be able to estimate it. Okay, so once again here, they're just giving us the formula for the confidence interval. It's your point estimate minus the margin of error is the lower bound. Upper bound is the point estimate plus the margin of error. But as you guys know, sometimes you need to go backwards with the formula. And that's what we're going to do in the next example here. Okay. So in the next set of examples here is going to say, look, what if you know the confidence interval already? Can you go back and determine the margin of error? So if you're already given a confidence interval, how do we find the margin of error? Well, what I like to do this in 2 steps. What I like to do is, if I do not know what my point estimate is, remember the point estimate is going to be the center of this confidence interval, right? Because the point estimate minus the margin of error plus and then the upper bound will be the point estimate plus the margin of error. So if you do not know the point estimate, all you have to do is find the center of your confidence interval. To find the center of your confidence interval, you would actually add the 2 points of your confidence interval together and divide by 2. And maybe we'll do that in another example. But really, the easiest way to get your margin of error, if you don't know your point estimate, is just do this. Just simply take your upper bound minus your lower bound and divide that by 2. right? Because it makes sense, right? Because if you take your upper minus your lower, that'll give you the total spread there. But remember, half of it was going to the left, half of it was going to the right. That's why we're dividing it by 2. Let's look at an example here. So we have the following confidence interval that goes from 54.2 to 56.5. Our job is to find the margin of error. Okay, this is a confidence interval for a mean height. Okay, so this is what you're going to do. To find your margin of error, I'm going to use the symbol E. Margin of error equals, we take 56.5 minus 54.2, and we need to take that difference and cut it in half. So divide it by 2. Okay. If you take 56.5 minus, let's see, 54.2, that gives us a difference of 2.3, which we need to divide by 2. Dividing 2.3 by 2, you get 1.15. So this is the margin of error. Okay, that is the margin of error. I'm gonna save calculating the point estimate for a later example, but yeah, for this one, if you need to figure out the margin of error, you just simply subtract your upper bound minus your lower bound, and then divide that difference by 2. Okay, let's see. Here's another one, except for this is a confidence interval for a population proportion. You do the same thing. Margin of error will be a 0.41 minus 0.33. Divide that by 2. That leaves us with a 0.08 divided by 2. Working out the math, you get a margin of error of 0.04 after you divide those. So that is your margin of error. Okay, so yeah, so now we're going to get into examples where now our job is to work backwards and see if we can get the point estimate. See if we can get x bar or the p prime. And so let me see here. Well, here they're just reminding us again how to get a margin of error via a confidence interval, but I think that's a typo there. Here we go. Suppose we know that a confidence interval for the population mean height in inches of a population is once again between 54.2 and 56.5. All right. So this is how you find your point estimate. So remember, for a confidence interval for a population mean, the point estimate is the sample mean. So x bar is the sample mean. And this is what you're going to do. Instead of subtracting like we did to get the margin of error, to get the middle of that interval, which is what the point estimate represents, I need to find the average of those two values. The average will put me precisely right there in the middle. So this is what you do. You take 54.2, you add to it. All right, remember this time you're adding 56.5, divide that by 2, and that will give us our x bar. So let's see, adding those up, that should be 110.7, I believe. If you add those up, we need to divide that by 2. Let's see, that should be 55.35. Okay, this is your x bar. All right. So remember, the question here is a little different. The question is not saying find the margin of error. It's saying find the middle, basically. Find the middle. And I believe they're going to ask us to do it one more time for proportions. Okay. Here we go. So we're going to take, so the center of this confidence interval will be P prime, sample proportion, equals to 0.33 plus 0.41. We divide that by 2. That's a 0.74. If I did my math correctly, please double check me. Over 2. Which gives us a quotient of 0.37, I believe. So P prime in this one, the sample proportion is 0.37. It's 37%. Okay. And just to kind of bring this all the way together, I know they didn't ask us to calculate E, but remember before we got the margin of error and we said that was the 0.41 minus 0.33 over 2, and it was 0.08 divided by 2, which ended up being a 0.04. And so now hopefully you can see where they're getting that confidence interval from, right? The lower bound for the confidence interval will be P prime, or the 0.37, minus the 0.4. And the upper bound will be, instead, add those values. And that's where they got the 0.33 going up to the 0.41. Okay, so hopefully that'll get you through this next homework assignment. That's how you calculate confidence intervals.